Let us try to understand how to use divide and conquer to generate or to get a minimum and maximum element from a list. Assume a list consisting of 3 elements. Now, like a binary search, divide this list into 2 parts, left and the right part. So there are 3 elements, integral divide by 2, that will give you 1. So 0 to 1 and 1 to 2. That will be our list. 0 to 1. That's a 10, 50, 20. 3 elements are there. 3 by 2. Integral divide, that means it will return 1. So 0 to 1, that means this element will be one list and this will be another list. So for this list, we will separately find the min and max. For this list, our min and max both are same as 10. For this list, let's call this the right list and that the left list. We will get a min and max. Our min will be 20 and max will be 15. Now let's combine both the values. So our next comparison for min will be 10 and 20, among that 10. And next this 2. We get our overall max as 50. So that's how it can be done. For instance, we have a big list. We divide the list into 2 parts. And for each of the list, we find min and max. Then for the other list, min and max. Then compare both min and max to find the overall min max. This process can be done recursively, like this left list, which consists of n by 2 elements, and the right list another consists of n by 2. For the left list, again divided by 2. So we have n by 4, n by 4. Find the min here, max here, and on again right side min here, max here, and solve that problem to find overall min and max. That's how you divide and conquer. You divide the list into 2 parts, then find the minimum and maximum of each of these sublists. Let's try to write the code. First, let's try to generate some random samples. Import random. Let's write count elements. Let's say we have 7 elements. That will be number of elements. Now we'll generate the samples. So we have samples is equal to random dot sample. The range, let's say from 0 to 100. Let's keep it small and clean, and count elements. So samples are there. Now let's try to find using Python's function. Find min and max will help us in checking our algorithm. Let's say min. Let's try to print. First, try to print the samples. Sample set is equal to samples print. Minimum is min of samples. Print maximum is max of samples. Try to run this code. Oops, we have an error. Let's try to print. We have 1 and 91. Let's try to go by our divide and conquer approach. Divide, conquer. So let's define a function min max We pass the samples, we pass the start position and the stop positions. These are the only three elements required. Next, what we do is, if we have one or two elements, let's say if stop minus start less than equals to 1, that is, we have either 1 or we have 0 elements, then what will we do is, we find our minimum. Before that, let's create a list. Our elements, make a list of two elements, the one indicated by start index and then one indicated by stop index. So we list these two elements, and from here we find the min and the max between these two elements. So we have two comparisons, elements next. We will return this minimum and maximum. This will work if there are 1 or 0 elements. Now next, try to go to the next part. If there are more elements, then we will subset this. We will find something called, not minimum, we'll first find the center index. That will be start plus stop integral divided by 2. That's our center index. So what we do next is find the minimum 1, max 1, and pass that sample. Instead of writing the start, we write start will be the same, but now we will use the elements up to the center, not the whole sample space. Secondly, we will find minimum 2 and the maximum 2, and again pass min max with all the samples. But now here we'll pass the center plus 1, that is the right element just beside the center element, and then up till the stop. Once we are done with this, we have two problems which is solved. Now we will compare only these two elements. That is, we make one minimum list and find the minimum among this. And then least underscore maximum. Maximum 1 and maximum 2. Now our maximum will be max of list maximums. Since we are returning by tuple, we will return this minimum and maximum. So that's the overall algorithm. Now let's try to run this with the samples. We expect two values in the tuple, so we make two variables and then call min max with the samples. Our start positions will be 0 and the stop position should be the n elements. The whole sample space need to be searched. Oh, it should be count elements. Whole sample space needs to be searched. From here, let's make that a different section. Let's try to print the minimum and maximum. Okay, we have an error. List of index out of range. Why is this happening? List of index. Let's try to print the start and stop positions to see what is going on. 0767. It was running out of bound because we passed all the sample space. It should be the index, not the number of elements. What if we want the number of elements? We can define it separately as a function. But for now, this is perfect. So what really is happening? This is our whole algorithm. We are passing in the whole sample set here and two indices, the start and stop indices. Let's basically keep track of where the element pointers are. In this, we are assuming that there are this part of the algorithm assumes that we have either 0 element left or 1 element left. So if it's 0 element left, that means start and stop are both pointing to 1, same value. And if it is 1 element left, then start and stop differs by 1, a value of 1. That is either it's start, then the stop will be start plus 1. It can be anywhere. What we are trying to do is trying to return the minimum and maximum element when that happens. So if there is no element left, that is the case of 0, then whatever is shown, whatever index we are passed in start or stop is the minimum and the maximum. But if we have 1, then it should be either that element or its neighbor. Then we have to run min or max comparison on these two values. So we are reduced to two values. For the next part, what if we have more than 0 and 1 cases are done, but what if we have 2, 3, 4, 5, 6, something like that elements? In that case, we find out the central point. This is our big array. We find out our central point, that is start plus stop by 2. Then we pass each of this new array to the min max function. This is min max left and min max right. Still, if there are more, like more than one element, then again partition this one. This partition is there into say min max. We run again. We have another array, sub array. So we run again this on this L a right side and on this L a left side. So we have a subpath. Again we go there, we have another subpath. This goes on until this part of algorithm is no more satisfied and we fall back to this part. Each of this now comes to the next part. When we have two, the L array and the right array, we pass it to the min-max function to determine individual minimum and maximum, that we call minimum 1 and maximum 1 for left side. Then for the right side we do the same. We get minimum 2, maximum 2, and ultimately this keeps on going. From this we compare to join. Now once the divide approach is done, we need to join the result. For that we will compare two minimums, minimum 1 versus minimum 2, to find out the overall minimum. So the lowest among this will be the overall minimum, and from the maximum we have maximum 1 and maximum 2. From this we get the overall maximum and return this as tuple. Since we are returning a tuple, we can also pass in two variables, like we have a tuple of minimum and maximum. This is assigned to this minimum, the second value is assigned to maximum. Now what will it pass to this function? We pass the sample space, the starting index, which is usually 0, and the stopping index. Stopping index, this should not be the number of element, is the stopping index. Stopping index, if you have n elements, then stopping index will be n minus 1. We have count elements, number of elements, so our stopping index is count elements minus 1. As we see, it works. Now let's try an example again. 7. So we have 1699. Yep, I have detected an error in my code. This line, as minimum 1 is compared against minimum 1, it should be compared again minimum 2. So both minimums should be compared, both maximums should be compared, and overall elements should be returned. That's why it was returning error. Now every time I run, it will return the proper value. Let's try it on a larger set. Let's try it on 20 elements. Okay, so 098. Fine. Let's try it on more larger sets. Let's try it on 100. Okay, 099, 099. Okay. Since we have 100 elements, all are covered. Let's increase the sample space to 1000. So we have something. Okay. Fine. Now our next step, since the program executes correctly, we will try to determine the most essential characteristics of a program. That's the complexity. Specifically, we are more interested in time complexity analysis. When there are 0 elements, say n is equal to, also number of elements is equal to 0, then what do? Since we have nothing, we do nothing, so 0. What if we have 1 element? Then that is the minimum and that is the maximum. What if we have more than 1 element? Then we can see here, if you have more than 1 element, it is actually partitioned into, like, a bigger list is partitioned into n by 2 and n by 2. For each n by 2, we get a minimum and the maximum. Let's say this is a L list and the R list. And then we compare the two minimums and two maximums to get a minimum and maximum. So we have to take the complexity of the right side, complexity of the complexity of the right side, the complexity of the left side, and two comparisons, that is plus 2. So for n greater than 2, our complexity will be the complexity for right side. Let's start with complexity for left side, let's complexity of for right side, then add 2. That is your overall complexity. Again, I mentioned time complexity. Okay, let's try to do the maths. Let us write this condition: t of n. Let's use smaller n. It's good to do smaller n in mathematics. So since we for zero element we don't consider the case, let's put it n is equal to 1 and n. Another one will be, we forgot the case, is n is equal to 2 and finally n greater than 2. N is equal to 1 means that element, there is only one element, let's say 10. So that is the min and that is the max. So there is no distinction. So there is only one operation. Sorry, there is zero operation. So we didn't need to do anything. Just directly when we see one element, we just print it as min and print it as max. Now what about we have two elements? Now we need to do the comparison. There will be one comparison for min and one comparison for max, or we can do it in one cycle, that whatever is the mean and the second is the max, whatever is not the mean is the max, so we can put one. But now let's come to the third part. Third part, what we are doing is, when n is greater than 2, we are dividing it into a sub list of n by 2 elements. Then so each of these will contribute to the time complexity. So we can write time complexity of this n by 2 list, time complexity of processing this n by 2 list. So these are L, R. Let's say this is L and R. And finally we get a mean, a max. Then we get a mean, a max. That's a mean 1, mean 2, max 1, max 2. Now we compare mean 1 to mean 2 and max 1 to max 2. These are two operations. First, mean 1 to mean 2, we get a mean. That's one operation. We do max 1 to max 2, we get a max. We get one operation. So total two extra operations. Now let us try to expand this. Tn equal to, so we can have, if we expand, we can have Tn by 2 plus Tn by 2 plus 2 operations. Instead of writing 2Tn by 2, you can again simplify it. No need for writing this. You can simplify 2Tn by 2 plus 2. So we can write this as 2Tn by 2 plus 2 for n greater than 2, 1 and 0. For 1 is for n is equal to 2, for n is equal to 0. For analysis of time complexity, what we do is Tn is equal to, first for n greater than 2, we write this. We'll go one step more and expand the recurrence relation. We will get 2 Tn by 4 plus 2 plus 2. This will go on and on and on until we reach, sorry, this will not be 0, this will be 1. You'll reach one element. That will summarize to the summation. If you complete it, will be like this. Since this part depends on the first order of n, that is n to the power of 1, we had Tn as 3n by 2 minus 2. Tn is proportional to n, and since Tn is proportional to n, our asymptotic relation, or big O, is equal to O n. Our big O notation is equal to O n. That's the time complexity. That is linear time complexity. But you should remember Although this is linear time complexity, this is best. But when you are searching for a min max by a normal method, like search for each element, you have the whole list, you go each element, finding one, comparing against mean, comparing against max, you will have a complexity which is given by 2n minus 2. Okay, that is your time complexity notation. That's a naive method where you compare each element to the minimum and the maximum and then change the minimum and the maximum. That's it for today. Thanks for watching. Bye bye.